Hi there, pre-calcers. Time for lesson 6.5, translations of sine and cosine. But we're really going to put together everything we learned in the last lesson along with this one here. This is a pretty important lesson because we'll be able to take any kind of transformation of a sine or cosine function and pick out the four key features of it and do some graphing. And then next week we'll also look at some applications of this, especially with taking and modeling some data. Alright, so anyway, here's our fancy new equation. You might recognize this b and this a from previous times, and we're adding the h and the k here. So let's just review a little bit. The b and the a. The b, of course, is the amplitude. Tells you basically how high and how low the graph goes. A, remember, has something to do with the period, but the period A is the period divided by 2 pi is what that A value is. And notice it's in the denominator of this function. Okay, now the two new ones are h and k, so let's tell you a little bit about those. So h is something called the phase shift, and it is the horizontal component. And then k, as you might guess, would be the vertical shift. And obviously the vertical component of the translations of the graph. So as you might recall, we said that the b and the a, notice they're multiplied and divided here, so that is a dilation. That's going to be some stretching and shrinking. The h and the k, notice though, they are either added or subtracted, so that's where the translations come in with this h and k feature of the graph. And just look at some examples here right away. So do you think you could find the phase shift and the vertical shift for these particular graphs here? So again, the phase shift, we're just focusing on this, and the vertical shift on what's outside. So the phase shift in this case, I'll say PS, will be pi, and it's going to go to the right. We like to identify whether it goes to the left or the right. The minus sign here, if you remember from when we did the transformations a few chapters ago, the minus sign actually meant to the right and plus to the left. And then the vertical shift then, of course, is with the 3 here, so the vertical shift is 3 up. So pretty straightforward. Now it gets a little trickier on the one over here. Let's take a look at the next one here, so I get my color right. Once again, if I look at the phase shift here, that's going to be the thing that's in the parentheses. Notice I have theta here for a variable, and theta and x really mean the same thing. It's just the variable we need, so don't be fooled by that. So the phase shift in this case will be 2, whoops, but it's going to be 2 to the left. Remember, the plus sign actually means a move to the left horizontally. And the vertical shift, that does do exactly what it says, so this one's going to be moved down 1, so 1 down. Alright, here's where we put everything together. Call it the big four, which is the amplitude, the period, the phase shift, and the vertical shift. So we have all kinds of features here. We're going to see if we can pick those out in this particular case. And it's kind of good to be able to write it in that form that we had at the start of the unit. Not the unit, but this lesson. So for instance, I'm going to write this a little bit differently. I'm going to write this as 5 times the cosine. Now what I really have in my numerator here is this whole thing, theta minus pi over 4. Everything there is in the numerator. I have a 1 in the denominator, and then it's plus 4. That can be kind of tricky. You might think that this 4 is in the denominator, but it's really, this pi over 4 is a constant. It's a number, so I can just as well put that in the numerator of this. Now when I want to pick out my big 3, or excuse me, my big 4, of course the amplitude is 5. That tells you the vertical component of the graph. What about the period in this case? Well, the whole reason I wrote it like this is so I could pick out that period. Remember that a value is the number that's in the denominator, and it's 2 pi times that, which tells you the period. So in this particular case then, it's going to be 2 pi times 1, which is just 2 pi. Now, what about the trickier ones, the new ones we've learned, the phase shift? So the phase shift in this case is going to be this pi over 4, and it's actually going to be going, because it has the less or minus sign there, it's actually going to be going to the right. So it's going to be shifted to the right pi over 4 units. And the vertical shift has something to do with this 4, of course. Since it's a positive 4, it's going to go 4 up. Kind of tricky, but we'll do another example. All right, this one's trickier. And the reason it's trickier is right here, because notice now we have a number in front of that variable. So I want to try to rewrite it so I have that single x in the numerator here. So let's see what we could do with that. So the negative 0.3, that's fine. But now I have to write this as the sine. And I'm going to factor out this 2 because I want to have just a plain x in the parentheses in that numerator. So if I factor out a 2, obviously I have an x there, but then notice I have to write my next expression as pi over 2, because obviously 2 times x would be 2x, and 2 times pi over 2 would get me back to pi. Now, how does that help us? Well, once again, I just need to write it a little bit differently here. So I have the sine, and then I'm going to have x plus pi over 2 in my numerator. And again, here's our middle school math. Remember that multiplying by 2 is going to be like dividing by 1/2. So that looks pretty yucky, but this will help us pick out my key features. So my amplitude is going to be 0.3, and notice I'm just going to put 0.3 here. I like to use just the positive aspect of it, or the absolute value of it. The period is always 2 pi times this a value down here. So in this case it'll be 2 pi times 1/2. 2's will cancel out, and my period is just going to be pi. Okay. My phase shift, once I have it in this nice form, is going to be pi over 2. Because it's the plus sign, it's actually going to be going to the left. And finally, my vertical shift then will be 1, but it's going to be going down because of the minus sign there. That's kind of tricky. We'll definitely be practicing on these kind in class to be sure. And lastly then, rather than giving you the equation and having you try to sort out those 4 features, we're going to give you the 4 features now and see if you can write the equation. So I'm going to change my pen color here to, let's see, how about this nice orange color here. So the amplitude's 5. It's going to be a cosine function, so for sure I know it's going to be 5 cosine. And the period's going to be 2 pi, phase shift negative pi over 8. So I know if that phase shift is negative pi over 8, it's going to be plus pi over 8 in the numerator like that. The vertical shift is minus 2, so that's just going to be a minus 2 tacked on the outside like that. Now the question is, what do I put in the denominator? Well, remember that that period, it says, is going to be 2 pi, and as we remembered that 2 pi times a equals the period, or a equals the period divided by 2 pi. And so if, I'll just write it like that, a is going to equal the period divided by 2 pi. Well, if we're given that the period is 2 pi divided by 2 pi in this case will just be 1. So that's kind of nice. So my final answer then will be y equals 5 times the cosine of x plus pi over 8. Nothing needed in the denominator since it's just going to be 1, minus 2. That's an equation that has the features that were prescribed in the original problem. So kind of tough going here. This is stuff we have to work at and practice at, but hopefully you watched this video and got some good basics down, and we'll continue to work on this in class. Alright, thanks for watching everybody, and we'll see you around.